1.2 million years ago, a volcanic eruption almost destroyed the breathtaking landscape that we cherish today. But now, something terrible is brewing deep beneath the Earth's surface, threatening to turn Yellowstone into rubble once again. Yellowstone System Alert just announced the massive dome-shaped uplift is still increasing in size. Let's unfold the mystery before it's too late. Yellowstone, located in Wyoming, is an absolute paradise for nature lovers. With its magnificent geysers and stunning Grand Canyon, the park offers a unique allure that draws visitors in. However, there is much more to Yellowstone than just its beauty. Did you know that half of the world's total geysers are found in Yellowstone? These geysers are propelled by molten hot rock, deposited underneath the surface by a previous quake. The heat generated by this magma gives us the mesmerizing beauty that Yellowstone is famous for. Despite its beauty, officials and engineers have been noticing changes in the area that could potentially lead to catastrophe. Yellowstone's magma has been pulsating quickly, similar to the last time it happened, which resulted in a large earthquake that could have killed millions of people. One particular area, Norris Geyser to the northwest of the caldera, has more than 500 hydrothermal features that are constantly changing. In addition, an area larger than Chicago has been inflating and deflating by several inches in erratic bursts for over 2 decades. It is scary to think about how this situation has escalated to such a dangerous level in recent years. But like everything of major concern, a study must be done to determine the cause of this activity in a place like Yellowstone. Have you ever wondered why a certain pocket of land has been breathing in and out? It's a phenomenon that has baffled scientists for a long time. But with the help of Denzel Dreisen from the U.S. Geological Survey's Cascades Volcano Observatory, some light has been shed on the matter. It turns out that Norris, the center of deformation, has been exhibiting this behavior for quite some time. But what could be causing it? To find out, scientists have delved deep into decades of satellite-based radar and GPS data of the Norris Geyser Basin. And based on their analysis, they've come up with a plausible theory. In the late 1990s, a body of magma intruded beneath Norris, causing fluids trapped within the magma to spill out and make their way through the rocky labyrinth above. As the fluids got stuck and pressure built up, the ground would rise, and when the fluids would escape elsewhere, the ground would deflate. But before you start worrying about an impending eruption of the supervolcano that creates Yellowstone, let us assure you that the findings don't indicate that. However, it does explain why the world's tallest geyser in the park has been erupting since March 2018. Researchers have even speculated that this might increase the likelihood of an explosion in the area. But this is still a subject of debate. However, amidst the complexity of this endeavor, researchers have uncovered a fascinating discovery. They have found that the injection of a massive amount of magma and fluids into the Earth's subsurface is a plausible explanation for the ground's unusual rising and falling movements. This realization has led scientists to view notorious thermal areas like the Norris Geyser Basin in a whole new light. Let's take a closer look at the Norris Geyser Basin, the oldest thermal area in Yellowstone, which is a scorching hotspot with a temperature of 459 degrees Fahrenheit, surpassing the boiling point of water. The Steamboat Geyser in the basin used to erupt infrequently, but has been erupting weekly since March 2018, setting a record of 48 eruptions in 2019. While the public is fascinated by this hyperactivity, scientists are more concerned about the dramatic quivering of the basin itself, which they consider potentially dangerous. But what does we actually mean by the dome-shaped uplift? Between 1996 and 2004, an 18-mile area in Yellowstone National Park rose 4.7 inches and then sank 2.8 inches between 2005 and 2013. From late 2013 to early 2014, it rose again at a record rate of 5.9 inches per year, but a magnitude 4.9 earthquake in March 2014 abruptly halted the uplift. Since then, the ground has fluctuated between sinking and rising until early 2019 when it started to subside. However, the basin remains around 5 inches higher than it was in 2000. Scientists are now focused on understanding the underground activities responsible for the persistent uplifting and subsiding of the basin. While the mercurial geyser's hyperactivity is interesting, the potential hazards posed by the movements of the Norris Geyser Basin are of greater concern to scientists. Geologists are studying the deformation of Norris Geyser Basin using radar and GPS data from satellites. The research has revealed that magma rose close to 9 miles beneath the surface, likely between 1996 and 2001, causing upheaval in the area. The basin sits on a line of faults and vents known as the Norris Mammoth Corridor, where two weak zones intersect, providing an easier way for magma to intrude. The magmatic intrusion responsible for the 1996 to 2004 Uplift event caused the ground to lower like a leaky balloon as magma-cooled fluids bubbled out in an upward spiral. This process lowered the internal pressure of the magma body, causing it to deflate, and the escaping fluid became trapped in pockets beneath layers of rock, causing the ground to rise in fits and starts ever since. Evidence suggests that magma-derived faults are sitting just beneath the surface of Norris Geyser Basin. Recent record-breaking eruptions of Steamboat, a geyser in the area, could explain the accumulation of magmatic fluids. The team wonders why some geysers are unusually quiet, such as the nearby Kindness Geyser. While major explosions are rare, a new blast could occur at any time, depending on whether fluids have moved close enough to the surface, increasing the likelihood of hydrothermal explosions. Despite this, the scientists are not moved by these findings. The rocky plumbing networks are remarkably complex, making small, undetectable changes constantly, decreasing the chances of a blast. The possibility of a blast is highly speculative and not something to worry about. This finding has led to the advice that the area is open to visitors. This supervolcano has the capacity to inflict global devastation in the event of a super eruption, and it's quite scary to think about. The caldera was formed during the last three big events over the past 2.1 million years, with the most recent eruption occurring approximately 630,000 years ago. The United States Geological Survey monitors the area between Wyoming, Montana, and Idaho to prevent a repeat of history. Some believe that the ticking time bomb may go off any time, while others think the link between Steamboat's hyperactivity and magma intrusion is circumstantial. Scientists are studying the fluids that surface to determine if they have chemical fingerprints of magmatic origin. Scientists can now predict the possible effects of another eruption. The last Yellowstone eruption was 1,000 times greater than the Mount St. Helens eruption that killed 56 people and animals and scorched hundreds of square kilometers of land. If another eruption were to occur, its effects would be felt worldwide. We could see falling ash, short-term changes lasting for years or decades, and pyroclastic flows affecting Montana, Idaho, and Wyoming. The scientists' unrelenting work is a testament to decades of accumulated data and modern scientific techniques. Pyroclastic flows, a phenomenon commonly observed during volcanic eruptions, are made up of a dense mixture of hot lava blocks, pumice, ash, and volcanic gas. These flows move at incredibly high speeds down the slopes of volcanoes, often following valleys in their path of destruction. Typically, a pyroclastic flow consists of a lower basal flow of coarse fragments that move along the ground, accompanied by a turbulent cloud of ash that rises above the basal flow. In some cases, ash may also flow from this cloud over a wide area downwind from the occurrence of the pyroclastic flow. It is crucial to acknowledge that pyroclastic flows can cause immense destruction, wiping out anything in their path, including large rocks, trees, and even robust buildings. While we should not immediately assume the worst-case scenario, it is essential to consider the potential devastation that may result from a volcanic eruption. As we move further away from the eruption site, the density of the ash will decrease, causing other regions of the United States to be affected only by falling ash. Volcanic eruptions of this magnitude typically result in the formation of craters, extensive volcanic depressions created when the Earth's surface collapses due to partially molten magma withdrawal. Although the likelihood of a significant eruption at Yellowstone is currently considered minimal, there is still a possibility. While the United States Geological Survey has ruled out such a scenario, the Yellowstone Volcano Observatory has presented evidence to suggest otherwise. The upcoming volcanic activity in the park is expected to manifest as either hydrothermal explosions or lava flows. While both are possibilities, lava flows are generally preferred as they move gradually along the ground, unlike sudden hydrothermal explosions, which are much more devastating. Although lava flows are still destructive, they are rare events, with the last one occurring about 700,000 years ago. Evidence of these past events can still be seen in distinct rock layers along the park's trail, and younger lava flows can be found near the cliffs surrounding the Upper Geyser Basin, which is home to the famous Old Faithful Geyser, a must-see attraction in the park. If you found this video informative, be sure to hit the subscribe button. So, considering the potential for a catastrophic explosion, it's comforting to know that a lava flow is a more likely outcome. However, the thought of any explosive activity in the park is still concerning. What are your thoughts on the possibility of a cauldron-forming explosion? Would you be worried about visiting the park during this time? Let us know your thoughts in the comments section below.